Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic, using reference angles. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we did today, or even on homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I've been linking my 11th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 3 parts, so leave a like, smash subscribe, and let's get started! Previously, we talked about reference angles, and we talked about how to find them. But what is the purpose of a reference angle? Why are we finding these reference angles if not just to find them? Well, what if I told you that reference angles actually help us eliminate the need to remember the entire unit circle? More specifically, when we're plugging in a value on the unit circle into a trig function, if we know how to use reference angles, all we really need to remember is the first quadrant. Now, if you have no idea what a reference angle is, or you need a refresher on either that or a coterminal angle, I recommend you pause this video. I'm going to be using both concepts in this video, so moving forward will most definitely confuse you if you are already unfamiliar with those topics. So pause this video and check out my earlier videos on reference angles and coterminal angles. You can find them right up here, and then come back to this video so you can see how you can use both of those with your trig functions. So today's question is going to be cosine of 240 degrees, and we want to find out what that value is. However, I don't remember the other quadrants. I just know that the first quadrant looks something like this. Can I use reference angles to find this answer? The answer is going to be yes. As long as you know the following 3 things, you can tackle this question. And the first is going to be, do you even remember what the first quadrant looks like? The second is, do you know how to use reference angles? Without both of those, you're definitely not going to be able to tackle this. And the third is, do you know what sign your trig is going to take depending on which quadrant you're in? With those 3 things under your belt, this is going to be no problem at all. So let's jump in and see what I mean. So like we said, we don't know any other quadrant. We just know our first quadrant, but we're starting with 240 degrees, which is definitely not in our first quadrant. So let's first start with finding our reference angle for 240 degrees. So our reference angle is going to be what? What quadrant are we going to be in for 240 degrees? Well, this is going to be greater than 180, but less than 270. So this is going to be in the third quadrant. So Q3 means that our reference angle is going to be found by taking our angle 240 degrees, subtracting 180 degrees, and that's going to give us what we need. So 240 minus 180 gives us 60 degrees. So if we are to find cosine of our reference angle, we're going to find cosine of 60 degrees. Now, looking back at our first quadrant, what is cosine of 60 degrees? Well, now you need to know, where is the cosine value? Well, remember, we said in my earlier videos on this, x comes before y, right? And the point, x comes before y in the alphabet. Therefore, c is going to come before s. That means cosine comes before sine. That's an easy way to remember that when you're looking at these values, cosine is the first, sine is the second. So if we're trying to find cosine of 60 degrees, we see that cosine of 60 degrees, this first one, is going to be 1/2. But are we done? No. We got to make sure we're having the correct sign. Now, we just said that c comes before s. However, we need to figure out what is the sign of c and s depending on what quadrant we're in. And we know that we're going to be in quadrant 3. Well, the x and y point in quadrant 3 is both going to be negative. Both of them are going to be negative. So that means that our c and our s are both going to be negative when we're in quadrant 3. Therefore, this answer should be negative. Therefore, our final answer for cosine of 240 degrees is going to be a whopping -1/2. And you see, we never saw any part of the other unit circle. We just looked at the first quadrant. Let's look at another example in which we're going to be using radians and see that we're going to do the same exact thing. So in this example, we want to use our reference angles to find sine of 2 pi over 3, assuming we don't know anything else about the other 3 quadrants, only our first quadrant. What is going to be the answer to this question? Well, the first thing is we need to find our reference angle. Now, our reference angle is going to be in which quadrant? So 2 pi over 3 is going to be less than pi, right? So that means that we're going to be in quadrant 2. So quadrant 2 means our reference angle is going to be pi minus 2 pi over 3. And when we subtract this, we're going to get pi over 3 as our reference angle. So this is going to be our reference angle. So sine of our reference angle is sine of pi over 3. And what is sine of pi over 3? Well, we look over here, pi over 3 up here, and remember we said that c comes before s. So we're looking at our second value. So sine of pi over 3 is going to be square root of 3 over 2. Square root of 3 over 2. That is going to be the answer for sine of pi over 3. However, are we finished yet? No, we don't necessarily want just sine of pi over 3. We were trying to find sine of 2 pi over 3, right? And which quadrant is this in? Well, if you have C and S, and we know we're in quadrant 2, in quadrant 2, our x and y are going to look like this. We have a negative x and a positive y. Well, we just said that sine is second, right? Sine is going to be second. So if y is positive, sine is also positive. So technically, this is going to be our answer. We don't have to worry about the negative here because y is positive. So our final answer is sine of 2 pi over 3 is going to be a positive square root of 3 over 2. Let's do one more example. In this example, we have something a little different from our first two examples, and that's the fact that we have to find cosine of a negative angle. And it's a pretty big negative angle. And we're going to use our reference angles to figure out what does this actually equal. Well, the first thing we have to do is make this angle a lot less negative. More specifically, we need it to be somewhere between 0 and 360 degrees. And to do this, we need to find the coterminal angle of negative 405 degrees that lies in between 0 and 360 degrees. So the first thing we have to do is take negative 405 degrees and add 360 degrees. And when we do that, we're going to get a negative 45 degrees. We're still not there, so we have to do the same thing again. Negative 45 degrees plus 360 degrees is going to give us a positive 315 degree angle. This is going to be in between 0 and 360, so we can stop here. This is going to be our coterminal angle. So our updated question is going to be cosine of 315 degrees. However, this is not in the first quadrant. So now we can use our reference angles. Since this is bigger than 270 degrees, we know this is going to be in quadrant 4, which means that our quadrant 4, how we find our reference angle is going to be 360 degrees minus 315 degrees, whatever our angle was. And that's going to give us a 45 degree angle. And this is going to be our theta r, our reference angle. So we can actually plug this into our cosine. Our cosine theta r is going to be cosine of 45 degrees. And what is cosine of 45 degrees? Well, cosine, remember, it's c before s. So it's our first one. So that means that this is going to be a square root of 2 over 2. However, is that it? Are we done? Well, let's find out what the sine is supposed to be. We're in quadrant 4. So our x and y for quadrant 4 are going to look as follows. We are positive x, but we have a negative y. However, this is cosine, and cosine is our first value. So we have a positive value. So technically, this is all we need to do. We don't need to add any negatives. Our true and final answer of cosine of negative 405 degrees is going to be square root of 2 over 2. This is our final answer. And notice, for none of these examples did we need to remember any other part of the unit circle besides our first quadrant. That is the beauty of having reference angles, but not just having them, using reference angles. So I hope you were able to follow today's examples and hope you now know how you can use your reference angles. However, if you have any questions about what we saw today, or even your own homework, remember you can put them in the comment box below, or visit me on my Facebook page, Tutor Me Sempai, and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping to help you with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Senpai.